Hello, my name is Ryan Thomas, and I'd like to share with you my presentation about heat and energy transfer. The transfer of heat is always taking place at any given moment. Without the transfer of heat and energy, life on this planet would cease to exist. The understanding of the three modes of heat and energy transfer, conduction, convection, and radiation, are essential in being able to develop new ideas and inventions that can either harness new energy or help to store existing energy for longer amounts of time. For instance, scientific advancements like harnessing the solar energy given off by the sun by means of solar panels, and also the production of nuclear powered plants and even nuclear powered boats were made possible by means of transferring heat and energy. I'll explain. Nuclear power plants use convection to cool the reactor core and move heat away from the core. Otherwise, the reactor would self destruct. So, without the knowledge and understanding of heat transfer, in this case being convection, we would have no nuclear power plants, submarines, or large vessels like those in use in the Navy and even the Coast Guard that make possible for intercontinental travel across the water. In the next slides, we'll cover conduction, convection, and radiation. Along with each slide, we will give a definition of each and examples of their applications. Now, let's take a look at the three types of transfers: conduction, convection, and radiation. Let's talk about conduction. Here in this picture, conduction is being shown by the red color of the pot and the red color of the handle. Now the handle is in direct contact, obviously, here with the pot. Now, as the pot heats up, the handle being in direct contact isn't in direct contact of the radiation waves, but the bottom of the pot is. So the handle is being heated by the pot because the handle is cooler, meaning the temperature is less, and as the pot particles heat up, they excite the cooler particles in the handle. Now, this will continue to happen until the entire system reaches the same temperature. Now, convection. Convection is being demonstrated by the water molecules. The water molecules here, and here are being shown directionally by the arrows as the eye heats the bottom of the pot through the radiation, which we'll talk next about. The particles move upward and the cooler particles move downward. Convection is defined as the warming or the heat transfer due to a moving substance. So in this case, it'd be the warming of the water molecules moving upward, causing the cooler particles to warm. And again, this will continue until the entire system reaches an equilibrium state of the same temperature. Radiation. The radiation from the eye, which is being demonstrated by what looks like radio waves, which electromagnetic waveforms, they do resemble frequency waveforms that you would see on an oscilloscope off an electrical signal. They're being emitted by the stovi upward or really to the left, right. Radiation waves don't have an omnidirectional path. They emit outward. So, as they emit outward, they heat the pot, which causes the pot to warms the water, warms the handle, which is the catalyst, I guess you could say, for the entire system to warm. Conduction. Definition. Transfer of heat between molecules upon contact at different temperatures until an equilibrium temperature state has been reached. Applications. Cooking, ironing, hand warmers, heating pads. The picture here demonstrates the same idea as the previous slide. The pot handle is being warmed due to the pot being warmed by the stovi. The pot handle is in contact with the pot. The pot warms first. The particles excite the cooler particles, and the handle begins to warm. The entire thing will continue to happen until an equilibrium state temperature has been reached. Convection. Definition. Transfer of heat by means of a moving substance. Application. Boiling water, cooling engines, cooling heating rooms, and warming near a fire. Here in this picture shows a fireman entering a room with a chair on fire. Now, as the fire begins to engulf the room, I guess you could say, the temperature rises. The smoke is warm. It's warmer than the air, which the firefighter is on his hands and knees crawling towards the fire. Because at the lower levels, the cooler air moves downward, the warmer air moves upward. It's kind of the same idea as the liquid in the boiling water. As the warmer molecules at the bottom of the pot begin to excite, they move upward and the cooler water molecules move downward. Here we have two different types of convection. There's a forced convection and a natural convection. The forced convection would be, in this picture, a fan blowing a heating element, which could be a heating coil of some sort, onto whatever material that's needed to be heated. Now, because heat moves upward, being forced, you're allowed to move the heat now into any direction in which the fan is blowing. In a natural convection, you have, in this picture, the cool air coming off of the water onto the land, which the land was being warmed or radiated by the sun, and the cooler air is kind of pushing the warmer air back upward, which is really the reason why you feel a breeze when you're standing near the shore side. Radiation. Definition. Transfer of heat as electromagnetic waves. Applications. The sun radiating heat to the earth, X-rays, radio communications, television, microwaves, and tanning beds. Here in this picture, we show the sun radiating its heat and energy towards the earth. Radiation coming from the sun is essential in life on the planet. Without the sun, life would cease to exist. However, the sun can be damaging with the amount of radiation it lets off if the atmosphere did not block harmful rays away from the surface. So, taking care of the environment and limiting pollutants is everyone's responsibility on this planet. Radiation in the medical field is such an advancement in modern medicine that without the knowledge and understanding of how it works, our medical professionals would literally be in the dark. As much as radiation can be used to save lives, it can also be harmful. In the high-powered areas of transmission, the radiation can actually harm the inside of the body, damaging sensitive tissues. This is another way of heat and energy transfer that should not be overlooked. Revisiting the first picture of this PowerPoint, the differences. The differences in the three modes of heat and energy transfer are illustrated in the picture. Conduction implies that there is contact with two surfaces. Convection implies that there is a movement of a substance that is the cause of the heat transfer. Radiation needs no physical contact. It simply sends out heat and energy in the form of electromagnetic waves that are then absorbed by another object in the form of photons. Here are the sources for the pictures that are used during this PowerPoint. My name again is Ryan Thomas, and I would like to thank you for your time, and I hope you enjoyed my PowerPoint presentation on the heat and energy transfer. Thank you.